Okay, in this video lecture, I am going to cover empirical formulas. So this is 7.4 part 1, empirical formulas. So an empirical formula is a chemical formula that has been basically simplified. Okay, so if I look at the actual formula of a compound, in this case NH4NO2, okay, I can simplify this, okay, to NH2O. Okay, because all of these can be divisible by 2. So the empirical formula is the simplest ratio of a compound. So when we look at ionic compounds, looking at the formula unit, it's usually the empirical formula because they just, what's the lowest number of charges to balance it out. For a molecular compound, however, that doesn't necessarily indicate the actual numbers. Okay, so if I'm looking at the gas diborane, which is BH3, that would be the empirical, but maybe the actual molecular formula is B2H6. So you notice how I can simplify B2H6 by, dividing by 2. So 2 divided by 2 is 1. There's my B. H6 divided by 2 would be H3. So how do we calculate empirical formula? You are going to convert the mass percentage of each element, and you're going to assume you have 100 grams of it. Okay, so they're going to give you a percentage of like, oh, you have, 25% nitrogen and 75% oxygen. So if you have 25% nitrogen, you're going to assume you have 25 grams of it. Okay, and then with the oxygen, if I had 75% oxygen, I would have 75 grams of it. That's the first step. So you're going to convert your mass percentage into grams. And then you're going to convert grams to moles. And this is an easy conversion. So one-step conversion. In order to convert from grams to moles of an element, you just need to divide by its molar mass. And then the third step is you're going to be given a number. And whichever number is the lowest, you're going to divide every other number by that lowest number. Okay, so I know this may seem really confusing, but once I show you the steps, you're going to be like, oh, this is easy. Okay, so here's our first example. 60%, okay, of a chemical analysis shows that it was carbon, 13.4% hydrogen, 26.6% oxygen. Calculate the empirical formula of the substance. So the first step I want to do is I want to assume, actually I wonder if I can just type. I'm going to type, see if I can save myself. Okay, so I have 60%. Okay, so that means I have 60 grams of carbon. Okay, 13.4% hydrogen is now 13.4 grams of hydrogen. And the 26.6% oxygen is now 26.6 grams of oxygen. Okay, and then I'm going to make this fancy and zoom out. Sorry, I should have done this earlier, and make it purple. Okay, so that's my first step. Convert your mass percentage into grams. You're just going to assume you have 100 grams of it. Okay, percentages have to equal 100. So here it is. Step 1 is complete. Okay, step 2. You're going to convert it to moles. Okay, so I'm going to get a green pen. Okay, when you do this, set up our conversion, go into moles of carbon. So the molar mass of carbon is 12.01. Okay, do the same thing for hydrogen. Set up my mole conversion. 1 mole is going to go on top. Molar mass of hydrogen is 1.01 grams. And then my last conversion down here. 1 mole of oxygen is equivalent to 15.99 grams. Okay, so now I'm going to punch this into my calculator. 60 grams divided by 12.01, I get 4.99. 4.99. Okay. 13.4 divided by 1.01, I get 13.26. And then the last one, 26.6 divided by 15.99, I get 1.66. So that's the second step. All I did was convert all of these to moles, okay? So the third and final step is compare the amounts of moles to find the whole number ratio. How do you do that? You find the lowest mole and divide everything by it. So looking at these three values, 4.99, 13.26, and 1.66, 1.66 is the lowest. So I'm going to divide everything by that 1.66. So I'm going to take 1.66 divided by 1.66, the 13.26 divided by 1.66, and the 4.99. Oh, what am I doing? Oh, man. Hope I didn't screw you up. The 4.99 divided by the 1.66. Okay, I got a little crazy there. This will give me a whole number, okay? So 1.66 divided by 1.66 is 1. 13.26 divided by 1.66 is 7.98. And then 4.99 divided by 1.66 is 3.00. Okay, these numbers right here tell you how many moles of that element you have. So when I write my EF, okay, I would go C, and then I'd look at this number. Oh, I have 3 carbon. Then I look at H. Oh, 7.9. This is really, really close to 8. Okay, you have to be really, really close to the whole number. I'll show you an example where you are not close and you have to do something else. So I have 8 hydrogens. And then oxygen, I just have 1, so I'm just going to write O. So here is my answer. Okay? All right. So I'm going to do another example here. I'm just going to copy this to see if it will save the purple, so I don't have to close out of my window again. All right, a dead alkaline battery is found to contain a compound of manganese and oxygen. Its analysis gives 69.6% manganese and 30.4% O. So the first step is convert your percentages to grams. You just assume you have 100 of it. So the 69.6% is now 69.6 grams of manganese. And the 30.4% is now 30.4 grams of oxygen. So that is step 1. Step 2, convert the grams of whatever element you are in to moles of that element. So when I set up my conversion, okay, I look at the molar mass of manganese. So I'm going to put my 1 mole on top. Molar mass of manganese is 54.94. And then I'm going to do the same thing for oxygen. 1 mole of oxygen is equivalent to its molar mass, which is 15.99. All right, so I'm going to punch these into my calculator. 69.6 divided by 54.94, I get a 1.26. 30.4 divided by 15.99, I get 1.90. So the third step is compare your moles, find the lowest, and divide everything by it. So 1.26 is the lowest, so I'm going to divide everything by 1.26. So this is going to be 1. And then when I take 1.9 divided by the 1.26, I get 1.5. Okay? So, you're like, oh, manganese, I have 1. And oxygen, wait a minute, this isn't a whole number. I can't write 1.5. So a lot of times you'll just have to double or triple it. Okay? to get to a whole number. You got to multiply it by something to get to a whole number. So if you got like 1.333, well, then you would probably have to multiply it by 3 to get to the next whole number. Because if you just multiplied it by 2, then you'd end up with the 0.66, something 0.66. So with this 1.5, that's easy. I'm going to multiply everything, okay, by 2. So I can get a whole number, because you can't have a decimal. So now this is 3, and this is 2. So when I write out my EF, MN2O3, and there's your answer. Okay, analysis of 10.150 grams sample of a compound known only to contain phosphorus and oxygen indicates a phosphorus content of 4.4333 grams. What is the EF of this compound? Okay, so they tell me how many grams I have of phosphorus out of the 10.15. And with all of this, we have to start with the percent. Okay, so I'm given this compound, and the total mass of that compound is 10.150. And from the 10.150, 4.4333 is phosphorus. So I can figure out the percentage of phosphorus, and then jump right into my steps. Okay, so there's like a little baby step before you get into the EF steps. So if I start off with the 4.4333 grams, right, and I divide it by the total amount, which is 10.150, and then I multiply that by 100 to get a percentage, right? Okay, 4.4333 divided by 10.150 times 100, I get a 43.67%. Here's my percent of phosphorus, P. Okay, so can I figure out my percentage of oxygen? You bet, right? 100% minus the 43.67%. I don't like the way I wrote my percent. I'll do this. 56.33. Percent oxygen. Okay, now I can just jump right into it. Okay, assume grams. This is gonna get messy. I'm gonna change my pen color to purple. 43.67 grams of phosphorus. And then down here, that is now 56.33 grams of oxygen. Okay, so I just completed step 1. Step 2, convert 2 moles by dividing by its molar mass of the element, right? So the molar mass of phosphorus is 30.97. And that is equivalent to 1 mole. And then convert the 56.33 grams of oxygen by dividing by its molar mass. So 1 mole of oxygen is 15.99 grams. Okay, now I'm going to punch this into my calculator. 43.67 divided by 30.97. I get 1.41. And then for the oxygen, 56.33 divided by 15.99, I get 3.52. So which one of these is my lowest? This one. So I'm going to divide everything by it. So this is 1. And then the 3.522 divided by the 1.41, I get a 2.5. Yep, 2.49, which is pretty close to 2.5. Okay, now, usually we would say, okay, my empirical formula is P because I have 1, and then O, but you can't write 2.5. Okay, so what can I do to the 2.5 to get it to a whole number? Oh, I can multiply it by 2. So now this is 5. I take the top, multiply it by 2, and this is 2. So my EF, I have 2 phosphorus and 5 oxygen. Okay, so this time they didn't give me a percent, they gave me a mass. And then from there I was able to figure out the percent and then jump right into my steps. Okay, last example. Magnetic iron oxide is 72.4% iron and 27.6% oxygen. So I'm going to paste my purple and save my finger. Okay, so the 72.4% Fe is now the 72.4 grams of Fe. And the 27.6% of oxygen is now the 27.6 grams of oxygen. That's first step. Okay, second step, I'm going to divide the grams by its molar mass and convert it to moles. So the molar mass of iron is 55.85. That's an 8. That's a 5. I got really slanty there. Okay. Down here, 1 mole of oxygen is equivalent to 15.99. Okay, 72.4 divided by 55.85, I get 1.29. And then the 27.6 divided by 15.99, I get 1.72. Okay, so that's the second step. Final step is look at your moles, find the lowest, and divide everything by the lowest. So the 1.29 is the lowest here. So I'm going to divide by the 1.29. So I get a 1 up here. And then when I take 1.72 divided by 1.29, I get a 1.33. Oh, man. Okay, so I don't have a whole number. So what can I multiply the 1.33 by to get to a whole number? Well, this 0.33, that's a third, right? So let's multiply it by 3 so we can get the next whole number here. So when I do that, I get 4. But whatever you do down here, you got to do up here. So because I multiplied it by 3 down here, that means I got to multiply this top number by 3. And I get a 3. So my answer is Fe3O4. All right, so that's how you do empirical formulas.